7.1 exercises. Evaluate the integral using integration by parts with the indicated choices of u and dv. The integral of x times e to the power 2x dx, where u equals x and dv equals e to the power 2x dx. The integral of the square root of x, the natural log of x dx, where u equals the natural log of x and dv equals the square root of x dx. Evaluate the integral from problems 3 to 36. The integral of x cosine 5x dx. The integral of y times e to the power 0.2y dy. The integral of t times e to the power 3t. Negative 3t. Redoing that one. Integral of t times e to the power negative 3t dt. The integral of open x minus 1 close sine pi x dx. The integral of open x squared plus 2x close cosine x dx. The integral of t squared sine beta t dt. The integral of the inverse cosine x dx. The integral of the natural log of the square root of x dx. The integral of t to the fourth power times the natural log of t dt. The integral of the inverse tangent 2y dy. The integral of t cosecant squared t dt. The integral of x, the hyperbolic cosine ax dx. The integral of the natural log of x squared dx. Redoing that one. The integral of open, the natural log of x close squared dx. The integral of z over 10 to the power z dz. The integral of e to the power 2 theta times sine 3 theta d theta. The integral of e to the power negative theta times cosine 2 theta d theta. The integral of z cubed times e to the power z dz. The integral of x times tangent squared x dx. The integral of x times e to the power 2x over open 1 plus 2x close squared dx. The integral of open arcsine x close squared dx. The integral from 0 to 1/2 of x times cosine pi x dx. The integral from 0 to 1 of open x squared plus 1 close times e to the power negative x dx. The integral from 0 to 2 of y times the hyperbolic sine y dy. The integral from 1 to 2 of w squared times the natural log of w dw. The integral from 1 to 5 of the natural log of big R over big R squared d big R. The integral from 0 to 2 pi of t squared times sine 2t dt. The integral from 0 to pi of x sine x cosine x dx. The integral from 1 to the square root of 3. Arctangent of open 1 over x close dx. The integral from 1 to 5 of big M over e to the power big M d big M. The integral from 1 to 2 of open the natural log of x close squared over x cubed dx. The integral from 0 to pi over 3 times sine x times the natural log of cosine x dx. The integral from 0 to 1 of r cubed over the square root of 4 plus r squared dr. The integral from 1 to 2 of x to the fourth power times open the natural log of x closed squared dx. The integral from 0 to t of e to the power s times sine of open t minus s closed ds. First make a substitution and then use integration by parts to evaluate the integral. The integral from e to the power square root of x dx. The integral of cosine of the natural log of x dx. The integral from square root of pi over 2 to the square root of pi of theta cubed times cosine theta squared d theta. The integral from 0 to pi of e to the power cosine t times sine 2t dt. The integral of x times the natural log of 1 plus x dx. The integral of arc sine the natural log of x over x dx. Evaluate the indefinite integral, illustrate, and check that your answer is reasonable by graphing both the function and its antiderivative. Take big C equals 0. The integral of x times e to the power negative 2x dx. The integral of x to the power 3 over 2 times the natural log of x. The integral of x cubed times the square root of 1 plus x squared dx. The integral of x squared times sine 2x dx. Number 47, part A. Use the reduction formula in example 6 to show that the integral of sine squared x dx equals x over 2 minus sine 2x over 4 plus big C. Part B. Use part A and the reduction formula to evaluate the integral of sine to the fourth power x dx. Number 48, part A. Prove the reduction formula. The integral of cosine to the power n x dx equals 1 over n cosine to the power n minus 1 x sine x plus n minus 1 over n, the integral of cosine to the power n minus 2x dx. Part B, use part A to evaluate the integral of cosine squared x dx. Part C, use parts A and B to evaluate the integral of cosine to the fourth power x dx. Number 49, part A. Use the reduction formula in example 6 to show that the integral from 0 to pi over 2 times sine to the power n x dx equals n minus 1 over n. The integral from 0 to pi over 2 times sine to the power n minus 2x dx, where n is greater than or equal to 2, is an integer. Part B, use part A to evaluate the integral of 0 to pi over 2 of sine cubed x dx and the integral from 0 to pi over 2 of sine to the fifth power x dx. Part C, use part A to show that for odd powers of sine, the integral from 0 to pi over 2 of sine to the power 2n plus 1 x dx equals 2 times 4 times 6 ellipsis times 2n over 3 times 5 times 7 times ellipsis times open 2n plus 1 close.